Our goal for this example is to develop a model for the two-span beam shown here. The beam is a W36 by 150 with two spans of 30 feet that is subjected to a uniformly distributed dead load of 800 pounds per linear foot and 12 kip live loads applied at the third points of each span. Ultimately, our objective is to examine the case where a variable load factor is applied to the dead load, as well as examine the potential of live loads that may or may not be present on the beam at any given time. During part 1 of this demonstration, we constructed the model and then applied the dead load and live loads, each in a single service case. During part 2 of this demonstration, we are going to separate the span 1 live loads from the span 2 live loads so that the live loads can be considered applied concurrently in both spans, as is shown here, applied only in span 1, as is shown here, and then applied only in span 2, as is shown here. Next, we'll modify the load combinations so that we consider both a maximum and a minimum load factor applied to dead load. And then last, we'll apply an envelope to consider the maximum effects resulting from these multiple load cases and combinations. For this demonstration, we're going to be using the educational version, version 21 of the VisualAnalysis modeling software. In VisualAnalysis, live load service cases may be given a pattern ID number to help model various loading patterns such as odd and even span loads. Each pattern service case is combined independently in building code load combinations from other patterned load cases. Loads in non-patterned live load cases are included in all patterned load combinations. For example, if odd span loads are defined as pattern 1 and even span loads are defined as pattern 2, then the building load combinations will be applied as is shown here, where L is the live load that hasn't been assigned to a pattern ID, L1 is the live load that has been assigned to a pattern ID of 1, and L2 is the live load that has been assigned to a pattern ID of 2. To include pattern live loads, in the model view, go to the loading ribbon, then go to the Load Case Manager dialog, and then create a new service case. The pattern ID can then be defined here. One thing to keep in mind, however, is that live loads that aren't assigned a pattern ID or are assigned the pattern ID of 0 as a default are included in all the different permutations of the load combinations that include the live load. I'll start off this demonstration by considering the two-span beam example that we worked with in part 1 of the demonstration. One of the first things I'll do is go to the loading ribbon and then go to the Load Case Manager, and you can see here that there are 4 tabs. We can edit the service cases. Those are basically the locations where the source loads are applied. We have load combinations, we have dynamic cases, and then we have advanced cases. Within the service cases dialog box of the Load Case Manager, you can see that we have both a dead load and a live load that are applied. The dead load has 2 loads, the live load case has 4 loads. And what that means is that the dead load case has one uniform load applied to the first span and another uniform load applied to the second span. The live load case, as it's defined now, has 2 point loads applied to span 1 and 2 point loads applied to span 2. So what we're going to do is we're going to create a new service case. I'm going to call this span 1 live. And I'm going to give this a pattern ID of 1. And I'm going to include it in the analysis, no self-weight, etc. Okay. It didn't show up because I'm not showing empty cases. It doesn't have any loads applied to it yet. So if I go in and click that dialog box, then all of the different cases that are defined, even those without any loads, are displayed. I'm going to create another service case. I'm going to call it span 2 live. And in this case, I'm going to give it a pattern ID of 2. All right, now one of the things to bear in mind is that any of the live loads that are applied with a pattern ID of 0 are applied in all of the combinations that include any of the pattern live loads. So when we go through the analysis of this beam, we want to include either the case of the live loads applied in both spans or the live loads applied in one span or the other. As we have it defined right now, VisualAnalysis is going to conduct the analysis with the live loads applied in both spans and then either span 1 or span 2. So in either of those two cases, it's going to apply those live loads twice in one span. So what I'm going to do is I'm going to delete this load case here, or more correctly, I'm going to go in and delete those loads off of the structure. So here are my live loads. This is load case pattern 0. And I'm going to go in and drag a window and delete those two loads. Do the same thing over here and delete those two loads. Now when we go back to the load case manager, you can see that the only service case that has any loads included is the dead load case. Now I'm going to create one more case, and I'm going to call this spans 1 and 2. Let's call it both spans live. And we're going to give this a pattern ID of 3. Okay. And let's close that out. I'm going to go now to apply my live loads, and I'm going to do this. I'll select that member. I'm going to apply a member load. It is going to be in span 1 live. It's going to be evenly spaced point loads. The first one will be 10 feet from the left, a load spacing of 10 feet, and a magnitude of -12 kips. Okay, it didn't show up. If I go up here and select the case span 1 live load, then you can see those loads appear. Let's do the same thing for span 2. Let me go here to span 2 live. There it is. I'll apply member loads. That pops up span 2 live. I want evenly spaced point loads, so I get 10, 10, and -12. Okay, there's span 2 live loads. And now let me do the last thing. I'll apply both spans live load, and I'll window over both of those members, apply member load, and we'll go to evenly spaced, and that should do it. Okay, now if we go in and select the results view, I don't get any nasty messages or warning messages over here. Then what we can do is plot our member graphs, and select both of these members and go there, and now you can see we have results for dead load, we have results for live load applied in both spans, we have results in live load applied only in span 1, and results for live loads applied only in span 2. And if we look at the load combinations, for each of the combinations that includes live load at all, we have 3 different permutations, one for each of the pattern IDs that we defined. Okay, so we could go in and look at those if we wanted to, like this, like that, or for both spans together, like that. The next thing that I'll do is I'll add in the minimum load factor 0.9 for the dead loads as we stipulated in the problem definition. And then to do that, what I need to do is to go again to the loading ribbon and then the load case manager and go to the load combinations. Now by default we're using the ASCE 7 2016 load combinations, and these are the combinations that VisualAnalysis thinks are appropriate based on the loads that we have defined. We have a dead load and a live load defined, so it selected those load combinations as being appropriate for those two service cases, dead and live. What I want to do though is include a custom combination, including a minimum dead load factor of 0.9 along with 1.6 times the live load is not something that's typically done, but I want to do it as a special case. So what I'm going to do is I'm going to create a factored load combination, and I'll call this, let's say I'll call it 2 min. Whoops. Oops. I'll call it 2 min like that, and that indicates that I have a minimum load factor on the dead load. So here's where we go through and define those. I'm going to put a factor of 0.9 there, and a factor of 1.6 there. And when I select OK, you can see that it added a new load combination here. It says 2min for the name. It's a custom type. And the effective equation, though, is not exactly what we wanted. Instead of giving me 0.9 times dead plus 1.6 times the live load, it didn't include the live load. And the reason why is that when we define that, we have to go through and we have to be very specific as to whether we're talking about the live loads that are applied in pattern ID 0 or whether we're talking about the live loads that are applied in pattern ID 1, 2, or 3 in our case. So I'm going to take this 1.6 factor, change it back to a 0. I'm going to come down here and I'm going to call this span 1 live. I'll give that a factor of 1.6 and I'll call that min span 1. Okay, and you can see what we've created there. Now I'll go ahead and create 2 more load combinations, one with the minimum factor applied to dead load and live loads in span 2, and then one with the minimum factor applied to dead loads and the live loads applied in both spans. 1.6 here. I'll call this 2 min span 2 and hit OK. Yep, that looks good. And this will be 2 min both spans. And I've got a factor of 0.9 there on dead, and down at the bottom 1.6 on both spans live. Okay, let me hit close. And now if we run our analysis, then you can see that we have multiple load, those new load cases, we have results for those. Oops, let me go ahead and window over this and make member graphs. There we go. Okay, there's span 1, span 2, and both spans. Okay, if we go back and look at the results case, one thing that's missing from this is an envelope of all of the different load combinations. Typically what we want to do is design our beam for the minimum and maximum bending moment or shear force at any given location due to any of the load combinations that's being considered. And those results are absent here. To include envelopes in our results cases, we return to the Load Case Manager, select the Advanced Cases tab, and then select the checkbox at the bottom of the dialog, and this gives us the envelope of the results. The visual analysis documentation says that you don't need this feature to find the extreme results, but in my experience that checkbox needs to be checked in order to see the envelope of the results on member graphs. When envelopes are requested, they are typically provided as both a low extreme and a high extreme, and you might find the maximum positive or maximum negative values in either of these two cases. However, again, in my experience, there seems to be little difference between the high extreme and low extreme, but frankly, I don't quite understand every nuance of this feature. To add the envelope results back to our model, the first thing I'll do is go back to the model view, then go to the loading ribbon. I'll go to the Load Case Manager, and then under the Advanced Cases tab, I'll select Calculate Envelope Results. Close this out and then go back and click on the member graphs, and when we go to look at our results, you can see that we have 4 more items added to this drop down. All cases low extreme, all cases high extreme, LRFD envelope low extreme, and LRFD envelope high extreme. If we compare the results of this envelope to the known results that we're after, you can see that there are some minor differences. We get the maximum moment of 220 kip feet. We get the minimum moment at the interior support of negative 300 kip feet. But look at the maximum moment at the interior support. Visual Analysis is predicting negative 81 kip feet, and our known result should be negative 177 kip feet. Also, look at the smaller positive moment in span 1. Our known result is showing approximately 13 kip feet, and Visual Analysis is showing 30 or 29 kip feet. The difference there is that we're considering extra cases. To remove some of these extraneous cases and combinations, what I'm going to do is go back to the model view, back to the loading ribbon, and to the load case manager. And I'm going to go to the service cases, and I'm going to select each one of these, and I'm going to modify them. And where it says including the analysis, I'm going to deselect that checkbox. So we can do the same thing by using this little checkbox down here at the bottom as well. And when we close that and now go back to our results view, if we look up here, that removes all of those service load cases. So we no longer are able to look at the results of just the dead load or just the live load in span 1. The only cases that we're allowed to, that we can see now, are the combinations that are defined. Now the next issue is that when we look at the envelope results at the bottom of this drop-down, we basically have two options. We can look at all of the cases that are listed here, or we could look only at the LRFD envelopes. So I'm interested in a combination of the both. If I select all of them, that gives me everything on this page, which is not exactly what I want, everything on the drop-down rather. If I select just the LRFD envelope cases, it won't include the combination that we just defined for min span 1 or min span 2 or min both spans, for example. So what I need to do is go back to the loading ribbon and load case manager again, and I need to exclude some of these LRFD combinations. But one issue is that when you select the default LRFD load combinations, it includes all of the ones that it thinks are relevant. So VisualAnalysis will put in all of the LRFD load combinations that it thinks it needs. And so it added load combination number 3, load combination number 5, load combination number 1, and we don't want those. So what I would want to do is eliminate some of them, but not all of them. And we don't have the option of eliminating just some of them. The only way that I know of to do this is to convert the ones that we want to keep to custom combinations. So I select those three. Those are the three permutations for load combination number 2. I select convert those to custom combinations, and you can see where they've been added here at the bottom. And now I can deselect the ASCE 7-16 combinations, and basically that leaves me with the 6 combinations that I want remaining. It's the 2 different permutations of load combination number 2 with a maximum load factor on dead of 1.2 and a minimum load factor on dead of 0.9. And then each of those 2 cases, each of those 2 permutations includes the live load in span 1, the live load in span 2, and then the live load in both spans. Now if we go and close this out, go back to our results view, now we can look at the results. We could look at the results of just the envelope of the LRFD combination, so that's these 3 combinations here, the custom ones that were defined. Or what we really want is we want to consider the envelope of all 6 of the cases, and that gives us the results that we're after when we set up the problem definition. So finally, after making all these modifications to the results in the load case manager, we are able to compare the moment envelope that we got using first principles, here shown in blue, with the moment envelope that we get from VisualAnalysis, and you can see that we get basically what we were after with this particular problem. Okay, before we close out this demonstration, I want to show you one more thing. It's, in my opinion, a quirk associated with VisualAnalysis. So what I've done is gone back to the version of this file that we started with. If I go here to the loading tab and look at the load case manager, under service cases I have only the dead load and the live load cases as they were defined when we started. So one of the options that's included in here is the option to include or exclude these load cases from the analysis. So you might be tempted to go in and uncheck that box and exclude those live loads from the analysis. And let me show you what happens if you do that. If you do that, you uncheck that box, then go to the results view to run your analysis. We can plot the bending moment and shear force diagrams for our different results cases. So there's the shear force and bending moment diagram for dead load. And if I go here, you'll note that live load is missing. So you might be inclined to think that if we go and look at load combination number 2, that this is the combination of 1.2 times dead load plus 1.6 times live load, where live load is 0, because we didn't include live load in the analysis. However, that's not the case. Even though we checked that box under the load case manager to not include the live loads in our analysis, when we look at the results from the LRFD load combinations, it still includes the results of the live load. So you have to be careful when you use these pattern live loads so that you don't define the live loads and apply more than what you are intending to. Now if we want to go back and select the load case manager again, now if we select this live load at this point and go down here and click modify, then there's an extra checkbox included here that isn't included in the main window. This allows us to exclude that load case from the building load combinations, the building code combinations rather. So if we do that, then go back and plot our member graphs. Here's our dead load diagrams, and then here are our load diagrams, our moment diagrams for load combination number 2. And now you can see that that live load is truly excluded from that load combination. Okay, thanks for watching. Hope this helps.